Hi, thanks for tuning in. Today we're going to change our CR-10s and make it direct drive using the Titan Aero from E3D. So we'll go over a list of kind of the basic materials we're going to need. Obviously, we're going to need the E3D Titan Aero kit. This kit comes with a bracket that we're not going to use, but it also comes with the compact but powerful stepper motor. That's the recommended stepper motor nowadays. They used to recommend that you could use the pancake stepper, but there's just not quite enough power behind that guy. So make sure you get that in the appropriate size, voltage, and mirror configuration. So they can either be like with the fan facing this side or mirrored and facing this way. We're using the standard version. Obviously it's 12 volts. The CR-10s is a 12 volt machine and it's in 1.75 millimeter configuration. I believe they're basically the same. They come with the collars for both 1.75 and 2.85 to guide the filament into the hot end. We're gonna use cable strippers, wire cutters. I always have a X-Acto knife. We're gonna use that for probably cutting off some of these straps. We need a Phillips screwdriver. That's for screwing in the screws on the fan. We're going to need a mount. I've printed off this mount that was made by CNC Kitchen. It's kind of a standard, simple, easy print. I've designed a different fan shroud. I had a little bit of difficulties getting his fan shroud design to work out well, and when I did, it was kind of brittle and snapped. So I made this. As a result, we're just going to glue this into the fan and then attach the fan to the back of the stepper motor. We'll cover that in a little bit. We need the glue for that. CA glue or super glue would work. We're using Tallman Complete. We're also going to have a collection of heat shrink tube to heat shrink all of the soldering connections because we will be cutting and extending these wires a little bit. We're going to make it kind of hot swappable, so that's just going to plug in and terminate here so we can unplug all the components and swap them out if need be. To do that, we're going to use Molex Microfit 3.0 connectors. You want a 2-pin 3.0 connector and the appropriate male and female pins for those if you're doing both ends. You can also use JST connectors, which are a little bit cheaper and more readily available for any of the low amperage stuff. So the hot end, you should be using a Microfit, but for the low amperage stuff like a fan, for example, you could use a cheaper DuPont or JST type connector, an array of Allen keys, and a soldering iron, soldering station, and flux and solder to make those cable extensions nice and secure. So you're gonna need a laptop, the mini USB cable to connect it to the printer, and we're going to be updating the firmware. We'll start, just for simplicity's sake, we'll start using the E3D Unified Firmware, whatever the newest version is at the time. And then we will go through the configuration options for the Titan Aero. We're going to make changes to things like the steps per millimeter for the Extruder stepper motor, because that's changed with the 3-to-1 gearing on the Titan Aero that gives us very precise extrusion. So let's get started. First things first, we're going to want to take the fan shroud off. We're going to cut these straps that attach the Bowden tube right now to the little nylon sleeve here. And then we're gonna pry back the nylon sleeve and cut the leads for the cooling fan, the hot end cooling fan, so the part cooling fan, hot end cooling fan, and the heater cartridge. We'll cut them pretty close to the bottom here. If you had the flush cutter snips, you could use that to cut these instead. Just make sure you don't cut into any of the wires. I decided to use the flush cutters instead of the X-Acto knife just to make sure I wasn't nicking any of the wires in the process. It's a little more controlled. So now we've got this all separated. You're probably best to mark what wire is what if you want to keep track of them. The hot end cooling fan is red and black, and the part cooling fan is blue and yellow. Then you've got the two whites, that's for the thermistor, and you've got the two kind of silicone sleeved ones, the red ones here. Those are for the heater cartridge. both the thermistor and heater cartridge, there's no like polarity to them. It doesn't matter which gets connected to which. There's no positive and negative, or positive and ground rather. So I'm going to cut these maybe just a little bit up here, so that if for some reason I wanted to reattach these to something else in the future, I have a little bit of length there to do so. Okay, so we're not going to use any of this. We can just set this aside. And then because this kind of keeps sliding down, you're best to tape this up to make sure it stays out of your way. So now there's just 2 more screws here that attach the hot end assembly to the X carriage. So now we want to disconnect the Bowden tube from the extruder. You should be able to push this collar in and pull the Bowden tube out. In this case, it seems to be more or less stuck in there. But because we're not using any of this extruder assembly going forward, I'm going to remove the entire assembly from the unit to remove some excess weight from the gantry as it moves up and down. So let's just start by removing this collar. There. So we flip the printer around, and to remove the extruder assembly, there's 2 screws at the top here that will begin to remove these plastic components from the top. And there's a screw here kind of at the lever, or the pivot point of the lever here. So start by removing those. And there's a lot of pressure on this spring. So before we remove this one, let's get the spring out of there. There we go. So now 1 more bolt up here, and there's 1 hidden underneath this lever here. Now make sure as you pull this last bolt out, whichever one you've left till the end, either the one under the lever or the one at the pivot point, make sure you grab your extruder motor here, the stepper motor, because it's going to fall and likely hit your glass bed. There we go. Unplug the cable, and then we should be able to just remove this entire assembly. This bracket here is the filament runout sensor, but because the filament is no longer coming in through here, it's going to go kind of direct in down the top. You would either have to get a bracket or mount of sorts to mount this up here so that it's in the filament path. In my case, I'm probably not going to use this for now. So what I'll do is I'll stick a piece of filament in there so that there's always filament in there. Basically accomplishes the same thing as the little short circuit board that the printer may have come with, but I don't happen to know where that is. So throw a piece of filament in there so there's always filament in it and it's not asking you to change the filament. So now let's start unboxing the Titan Aero. There's a bunch of little components, so I suggest you leave them in the bags until we're ready to come to them. So here are the 2 filament guides, these little black kind of triangular pieces, 1 for each size of filament, the thumb wheel, and the extruder gear. You've got a silicone sock, as they call it, which wraps around the heater block. This helps thermally insulate the heater block, especially if you have a quite powerful cooling fan that isn't blowing right at the tip of the nozzle. It may be blowing on the heater block a little bit. If you don't have decent thermal insulation and you do have it blowing on the heater block, you can end up in one of those thermal runaway conditions where the printer shuts itself down because it's calling for heat, but the temperature is not rising quick enough. And that should be enabled in all good firmware. I don't believe it is out of the factory, but the TH3D Unified firmware and base Marlin firmware both have it enabled. You've also got the heat break, which is kind of like a threaded tube. And then you've got the nozzle, which is a 0.4mm nozzle by default. And wrapped in that silicone sock is the heater block that all of that slides into. These pieces I'll actually open up. Okay. You've also got a small packet of a heatsink compound, as they call it, but like a thermal grease. You will add this on the heat break, but only on the section of the heat break that goes into the aluminum fins to cool the hot end. So you are not going to put the thermal compound on the threads that go into the heater block like this. okay? Only on the top part. There's the stepper motor. This is a 0.9 degree stepper motor. So by default, stock, it comes with a 1.8 degree stepper motor. That means you get 200 steps per revolution. And on a 0.9 degree stepper motor, you're gonna get 400 steps per revolution. So you've already doubled your precision. And then you add in the fact that it's got 3:1 gearing ratio, and you've just multiplied it by that much more. This kit happens to come with a kind of standard mount bracket. This is not appropriate for our installation, so we're not going to use this. That is why we printed this one. You've got kind of a stepper cable that just has a 4-pin DuPont connector on the other end. We may make use of this if we decide to extend some of the stock cables for the stepper motor, or we can use the Creality official extension cables to do that. You've got some length of wires which can be used for the thermistor. You've got the thermistor itself, which also has a MicroFit 3.0 2-pin connector on it. So that will plug right into one of the ends of this wire, and we can use that. So you wouldn't actually need the crimp connector for this one. We can just steal it from here. You have the cooling fan. So this will attach to the aluminum fins to cool the hot end. And actually inside here, this is a few pieces. So you've got the heatsink, which is kind of integrated. This is basically a V6 integrated into a Titan extruder, so it's all in one. You've got the Delrin machine gear and the little hobbed bolt to grab the filament. There's a washer, or not a washer, there's a bearing that's already pressed into this piece, and there is a bearing that will go into the opposite side. So those bearings are for this gear. A whole bunch of little pieces, springs, screws of varying lengths depending on how thick your mount is, Allen keys. We'll keep all that in there. There's also the small set screws for holding in the heater cartridge and thermistor cartridge in the heater block. Some more small bits, including the other bearing that we were looking for. And there seems to be a screw out of the packages. And this is kind of the idler. This puts pressure against the filament to make sure that it's coming into contact with the feeding gear, the hobbed bolt here. There's also a small piece of PTFE tubing. So this small piece of PTFE tubing goes inside these black filament guides, and we need to cut it to a very specific length, but we'll cover that in a second. So now we'll attach the bracket to the X carriage here. We should have enough spare screws from removing the extruder motor and assembly to attach this. We can also use the screws that used to hold in the fan shroud. They should be long enough to reach. You may need to drill out some of these holes if there's not quite enough clearance to slide over top of these prongs. It should be a tight fit though. And you want to make sure that the back of the bracket is flush against the X carriage. But in my case, the washer for this bottom nut here is a little too high, and it's kind of pinched between this new mount and the X carriage. So I'm going to, at the very least, loosen this and slide that washer down, or I may actually remove the washer. So this assembly, when you take it off, this bottom wheel has the eccentric nut. So the way it's assembled is the bolt goes through the wheel. There may or may not be a washer here. Then the eccentric nut with the small protruding section facing forward, that goes inside the metal bracket here, and then washer and nut back on there. So just kind of take note of that. So I've got the nut back on there. I ended up removing the washer entirely because there was no way to make this sit flush with that washer on there, and make sure the nylon lock nut is tightened securely. You'll see there's a lot of play in this entire bracket right now. That's because that eccentric nut needs to be adjusted. So use your wrench and adjust that so that there's enough tension, number one, that it doesn't wobble around anymore, and number two, that if you rotate each of the wheels by hand, the entire carriage should move. Perfect. Okay, now we can actually start bolting this on. So now we're going to use the M3 screws through this hole and this hole. You could also add one of the very short M3 screws here, maybe with a washer around it. In our case, we've printed this bracket out of polycarbonate. You can also use ABS or ASA for higher temperature resistance. PLA will be just fine, and if it ever sags or gets soft for some reason, you could always just print another one. So if you've opted to put a screw here, it's optional. Put it in the furthest away from this kind of center line. If you put it in the one over here, that's actually where this larger gear goes. There's a little notch out in this bracket to allow a little extra clearance. So we just don't want to get too close there. That would probably obstruct the motion of this gear and even potentially chip off a tooth or something. I've seen it done both with and without. I prefer to add more screws than not. So let's get the easy bits out of the way. We're going to take this black bracket and the stepper motor, and they kind of sandwich on either side of this bracket. As you're adding the stepper motor, keep in mind where you want the cables to come out. If you want them to come out the back, there's very little clearance there. In our case, we'll probably just put them right out the top. And there should be a very tight fit between this little ridge here, this larger circular ridge, and the hole in the bracket. You may even need to take a set of, or an X-Acto knife there just to kind of shave it out so that it fits in there snug. This one happens to fit very well. And then there is one black screw that's included in one of the little bags of screws with the E3D kit that goes in this hole here. It's kind of a set screw that screws into this bottom screw hole on the stepper that kind of just holds this in place while you can align everything else. So let's find that screw. Yeah, it's a little black one in the smallest bag of screws. So this bag contains the grub screw, or the little set screw, for the thermistor cartridge, the black screw that we're going to use as like a set screw to hold this bracket, 4 self-tapping screws for the fan that's going to connect into the aluminum heatsink, a bearing for the large gear wheel, and a washer. So that set screw has now made it so that this is not going to fall off. There's still 3 more screws that need to go through the other holes, but we'll come to those in just a second. At this point, you should refer to E3D's documentation, but there's a specific alignment that they recommend for the large and small gear. The teeth on the large gear face out that way, and it slides into that top hole where the bearing is already press fit into. And this, using the grub screw, slides onto the hole on the stepper motor, and the fronts of these 2 gears should be flush with each other. That'll take some fiddling with to make sure that they're in proper alignment, but make sure that this gear is not protruding out the front. Now we'll get rid of some other little bits before we start assembling the hot end. I've got the thumb screw, and in this bag there's the kind of tension spring for the lever. And then the lever with the little idler. So the lever with the idler goes on the stepper motor like that. And then there's a little nub on it where the spring goes on. And there's also a nut that threads onto the end of this thumb wheel. There it is. So this is a nut with no like nylon lock nut or anything, just a regular nut. Thread that on first. That's what helps you or allows you to adjust the pressure on the spring. So placing that like that and just slide it onto that little nub, and it just rests in this bracket there. And I find it's easiest to put a little bit of pressure to kind of hold all those pieces in place. It's a little bit counterintuitive. righty-tighty, lefty-loosey normally. But if you move this counterclockwise or left, it actually applies tension as that nut slides down the thumb wheel threads. Okay, so now let's move on to assembling kind of the heater block and the heat sink for it. So this heater block, unlike the one that is used stock on the CR-10 and others like it that use kind of a pinched thermistor on the side of the heater block, this has a cartridge style thermistor that actually goes inside the heater block, which should ideally get you a more accurate temperature reading just by the very nature of how much surface contact there is. And that thermistor has a small hole in the bottom for a small grub screw, which would be in one of these little bags. Yeah. There we go. So you want to apply pressure so that it doesn't, slide out or move around, but you don't want to crush the thermistor. So just enough that you're confident that it's not going anywhere. Perfect. Now, on the bottom, there will be 3 holes, and on the top, there's only 2. So that's how you know what the orientation of this is. And so just to keep track of that, I'm going to loosely thread in the nozzle in the bottom. The other kind of dead giveaway is that there's 2 holes in the bottom of the silicone sock, one for the hot end and one to allow you to get to the screw. This is the screw that allows it to pinch on top of the heater cartridge. So now, this is the heater cartridge. They give you, I think, 1 meter of wire for this. Because we're using most of the stock wiring, we're not going to need the whole meter. We'll probably use just a little bit of it. For now, I'm going to leave the leads long. And out of the same side, I'm going to place the heater cartridge. And then you're going to insert the one small M3 screw we're left with in this sachet that we just opened. You're going to insert it in the bottom, which is unthreaded, and the top section here is threaded. And this right here, you should see it kind of deform as it squeezes onto the heater cartridge. I believe they recommend that you put a washer there in between the head of the little bolt here. And as you're tightening and it starts to put pressure on the heater cartridge, you want the heater cartridge to be centered. So just make sure it's not kind of poking all the way out the one end. Okay, so now we're going to take the heat break and the heat sink and we're going to screw these 2 together. As I mentioned before, we're going to put the thermal grease on this larger portion that screws into the heat sink. Careful with this stuff because it gets everywhere, and have like a tissue or something nearby so that you can wipe off any excess if it squirts out. And you don't need very much at all. So I've kind of just made sure it's wrapped around, and that will ooze out a little bit as we screw it in, and then we'll wipe up the excess with a tissue. So now we're going to screw the heater block onto the heat break here, and we hand tightened this before. Just back it out just a little bit, maybe 0.5 millimeter or so, and then screw these 2 together. So as we're threading this on, eventually it'll kind of come into contact with the nozzle, which we just hand threaded in earlier. But it's kind of important to keep in mind which way these wires are going out, depending on what kind of amount you have and where you want to route them. In my case, I want these wires to be routed towards the front, and then we're going to kind of connect them up like this, so to speak. So as you start tightening, you'll want to play with how far in this nozzle is to make sure that it contacts the heat break in such a way that they're not going to move. But this nozzle should also not be out 1 millimeter here. That may end up meaning that you need to put both your thermistor and heater cartridge in the other side to kind of reverse which side they come out. So in my case, I've now got the nozzle nearly flush with the surface. It's tight against the heat break, and this is kind of the orientation in which the heater block is. And that means the wires are going to be leading out the back, and I want them leading out the front. So what I'll do is loosen this pinch screw and this grub screw and pull the thermistor and heater cartridge out and put them in the other side. Perfect. So now that we've got all of this connected, let's get these wires out of the way. We need to insert the bearing into here. It's kind of a tight fit and it just snaps in there. And then this would get connected onto here. Before we do that, we need those black guides that kind of guide the filament through into this hole. So these two filament guides, they're labeled depending on the diameter filament you're using. So we're gonna toss away the one that says 2.85. We're only using 1.75. And this kind of sits here with the flat surface touching this flat surface here, like that. And it will be kind of held on there by a piece of PTFE tubing that's going to go just in the cold side here and then up through right to the top here. So we'll cut one of those and we'll be back in just a second. So through trial and error, I'm sure there's a proper measurement for this piece of PTFE tube, but I cut one intentionally long, slid it in here, and then slid this into the heatsink. And initially it was, sticking up this far, and I just took piece by piece off of it until it sit in there just barely flush. You don't want there to be any slop or gaps in that pathway. You want it to be consistently 1.75 millimeters or just a little bit higher depending on how thick the PTFE tube is. But you don't want gaps at the top or the bottom, especially if you're going to be printing any kind of flexibles. So now we can bolt this onto the rest of the assembly. You may need to, because we only have one screw holding this bracket in place, if you remember at the bottom, you may need to kind of wiggle the assembly to make everything kind of line up. And it's a good idea to loosen that tension on that spring if you added any, so that it's not kind of twisting the large gear. With any luck, everything just lines up, and make sure that the gear moves and isn't contacting the back of the bracket or anything else. And then we can go ahead and start, there we go, we can go ahead and start adding in our 3 screws, 1, 2, and 3 at the top here. So they give you screws of various lengths, depending on how thick this wall is in your bracket. This one is 2 millimeters, so we'll find screws that are an appropriate length for that. And in the case of, here we go. In the case of each of these screws, if you line it up, you can kind of get a feel for if it's long enough or if it's too long. They can't come right to the back here because only a portion of this block is threaded, but that wouldn't have any bite into the stepper motor at all. So we'll get the slightly longer one for that. And this bottom screw here, because we use the set screw to screw into the stepper motor, there is a little nut embedded into the back of this bracket. So that bottom screw doesn't actually have to reach from here through the bracket and into here. You just want it to reach into the very back of the bracket, or maybe flush with the front of this face. So for that one, this looks like a good length. And don't tighten any of these all the way down until we've got them all in and we make sure that everything lines up. And it's definitely a good idea to make sure that your bolt holes in your bracket are sized appropriately to fit these screws through before you get to this stage, otherwise you're taking it all apart again. So this screw is very important because this one goes right through the center of the gear and keeps everything aligned. Make sure that it's good and tight. Also make sure it's this appropriate length like you did with the rest of them. And then this bottom one, as I mentioned, we're going to use a much shorter screw, and it should just be, I don't know if you can see this here. It screws in just like this one, so we can use this as a reference point, but it should be just long enough to reach the bracket and not go through the bracket. So this one should do. If you choose too long of a screw for this one, it won't go in all the way. The head of the screw won't be flush with the aluminum heatsink. There we go. Okay, so everything lined up. Now we can just go around and make sure that they're all appropriately tight. Nothing too crazy. There we go. So now we can attach the fan. So these are self-tapping screws. They tap right in between the fins on the heatsink. And as you're doing this, just kind of keep in mind where this lead is coming out in relation to where you want to route your wires. Everything for me is coming out the front, so I think maybe it makes sense to just have this one also come out the front and I can bundle them all together. These are Phillips head. Now you don't need to go too crazy with these. I've found that they strip rather easily. You just need enough that it's kind of flush and held firmly against the heatsink so it's not rattling around. So especially as I'm screwing those in, I was using my hand to support the carriage so that it wasn't sliding backwards as I was putting pressure against this side. It may be a good idea to completely disconnect the X-axis stepper motor if you haven't already, so that if you do end up moving it like this, it doesn't induce voltage backwards through the system, which can blow your stepper drivers or your board. For a fan, we've chosen to use a 5015 or 5015 radial blower fan. Instead of an axial fan that blows this way, this is like a squirrel cage type blower, and it blows it out this hole. These typically have a much higher static pressure rating than an axial fan. They're also relatively quiet. And I've designed, because I'm not using the fan shroud that is meant for this mount, I've designed a fan shroud with a little lip that will go inside here. It fits pretty firmly. I don't trust that that would stay on under any kind of vibration, but what I will do is apply a little bead or a couple drops of super glue and super glue this in there. If this fan did fail, I'd be able to break that glue free and pop it off. Worst case scenario, I have to print another one. So before you glue it, make sure that you have the fan oriented appropriately. That means that the intake for the fan should be on the outside, so it's pulling in fresh air. If you have the fan flipped, you could end up attaching the mount, and not only will it not be in line with the hot end, but it won't be getting any fresh air because the fan intake is going to be kind of flush against the back of the stepper. In our case, we're just going to use a 3M VHB adhesive, I think, for now. I may get around to finishing my design for the mount assembly that has a bracket for this fan to sit right into. But for now, that will work. The one nice thing is that also allows us to adjust the height of the nozzle tip. So it'll be about there with the tape. If we had a volcano suddenly, we could end up adjusting this further down so that it's pointing at the tip on the volcano, which sits down a little bit further. So the stock wires that we cut earlier, blue and yellow, were for the cooling fan. Blue is ground, yellow is the positive. These are PWM controlled, so if you hook a voltmeter up to it or something similar, you'll see the voltage fluctuate all over the place. But you'll want those to match up with, ground and positive on this side when you connect them. The hot end cooling fan, so that would be this guy now. These are just standard color coded, so match those up with this. We've connected the extension leads that came with the Titan Aero kit using the Molex connector. And so we'll snip this off a little ways back here, and we'll solder that to the black and red accordingly there. We'll do the same with the thermistor. It doesn't matter which is connected to which, so we'll cut this a little while back and we'll connect it to the two white ones. And then we will do the same with the heater cartridge. Now the heater cartridge doesn't have any quick fit connectors. So we have a couple options. We can crimp on the microfit connector like we're going to do, or you'd be able to just solder that on to the two red ones here. Okay, so we're back after a little while. I find crimping these connectors a little frustrating and time consuming at times, but it makes it all worthwhile being able to quick disconnect when you need to change something. Maybe something gets caught up on a messed up print and torn. It's easy to quick swap it. So now that that's done, we need to deal with a couple things. The cooling fan, part cooling fan. As I mentioned, this is going to be 3M taped to the back of the stepper, and then the front of the fan will be right beside the nozzle. The other thing we need to do is a little bit of wire management. So I might reuse some of these stock parts, bolting just this top frame without the lever and spring back here with some M3 screws and nuts on the bottom. And then using the Bowden tube, I might need a little bit longer of a Bowden tube, but we'll see. I've drilled a hole in the top of the bracket, and you can just kind of press fit that in there. And now you can use that as a way to kind of zip tie your wires this way. There we go. Zip tie your wires all along this route, and then that way it will keep them from sagging down into your print. And you'll want to, do a little bit of wire management, clean up down here, maybe even zip tie that there to keep that in a nice, neat little bundle. So I'll spend some time to do that, and we'll be back. So I've bundled up the wires using zip ties, and one of the things that I should mention is we are using the stock extruder motor cable. Now this cable was inside the sheath of cables that only led to this bracket where the extruder stepper motor used to be. As a result, it's not really long enough for permanent installation. This would be about the highest Z height we'd be able to go and still have enough slack, and that's with the box directly beside the printer. If we try to move this any further away, there's really no slack to do so. So there's a couple ways that you could manage this. If you have the set of Creality extension wires, then that will also come with another extension wire for this. So then you'll have plenty of play, and you'll also be able to move the box further away or outside your enclosure if you happen to have one. The other thing we can do is the E3D kit came with this stepper motor cable, and it has a DuPont connector on the other end in case that was plugging right into your board or something. You would want to take a JST connector, like one of these, and crimp the little male pins onto the end here in place of this DuPont connector. Then that way you could have this stepper motor cable connected to here, and then this end is already prepared to plug into the stepper motor, and that'll give you about another meter of length. But we'll just, in the interest of time, we'll just run it like this for now and do a small height test print, and we'll probably get the full set of Creality extension cables to do this permanently. So we're ready to tighten up the nozzle. If you remember, we only finger tightened it. So you want to heat up the whole hot end to operating temperature. I'm using about 210, 220 degrees right now. You want to make sure that you're holding the heater block with a spanner wrench so it doesn't rotate around while you tighten the nozzle itself. So find a spot to grab the heater block where you're not crushing the thermistor wire. It's a little fragile, so just be wary of that. And then give it a good tightening. Good. So now that that's tight, there will be no play or wiggle in the hot end assembly at all. Careful, because it's hot, but we're going to put the silicone sock on. Make sure it's oriented appropriately. And that just clips on there like that. Now these will get a little bit soft over time, so they'll need to be replaced. And of course, if you have a failed print, they can get torn as they get kind of tangled up in the mess. There we go. So that will keep a more stable temperature on the hot end. It'll also kind of protect it against any of the cooling fan that happens to be blowing on the side of the hot end. But we've taken the time to kind of choose an appropriate height for the cooling fan here. So we can cool this guy down now. And I'm going to move the filament roll holder to the top. This makes a little bit more sense. It used to kind of feed in the side here, and now it's going to feed directly down and into the top of the Titan Aero. To attach this to the top rail, you're going to need some screws and T-nuts. So I'm using M4 screws and M4 T-nuts. I've got some in the spare parts bin. You should have a couple spares that came with your printer. Make sure that the screws aren't too long, otherwise they'll hit the extrusion inside there. And you'll probably have to drill out your holes here. I think they're drilled for M3s, which are what these were. Don't be afraid to do so, and you can always go back to using those thumb screws if you want to change back. So now I'm just going to kind of test feed some filament in, and you'll want to straighten this as much as possible as you're putting it in. And it kind of helps to cut this on a 45 or so. There we go. So now put pressure on that lever, and it should slide right down to the bottom. There we go. And just make sure that the thumb wheel is adjusted to apply a decent amount of pressure. You'll kind of have to do that by feel. There. Perfect. So now we're ready to plug in our laptop. We're going to clean up our workstation here, plug in our laptop, and we're going to open up the Marlin firmware and configure it for the Titan Aero. Okay, so I've got the Arduino IDE open and I've downloaded the E3D unified firmware. This is a lot easier than configuring Marlin from scratch. We're using U1R19B. So if you're using a different version, the line numbers may be a little bit different. So let's open configuration.h. This is where we're going to do most of our configuration. We want to uncomment only one printer. So we're going to uncomment the CR-10s. Uncomment by removing those two slashes. And you could disable the filament runout sensor. As I mentioned, I'm going to kind of leave my options open. So I've just stuck a piece of filament in there, which makes it seem like it always has filament, but allows me to quickly kind of undo that and use it if I choose to. So then we will not need any of these things. And we're going to look for printer name. So I'm going to call this for fun. And let's go. I'm also going to disable the boot screen here. This just makes the printer boot a little bit faster. And where are we? Sorry, it's called Titan. There we go. So under the E3D extras section, we're going to uncomment out Titan Extruder. So this tells it we're using a Titan Extruder. And if we're using just the Titan Extruder itself, not the Titan Aero setup, that would be enough. But we're using a 0.9 millimeter stepper driver, and E3D's documentation tells you to use 836 as a starting point here. You would want to do some extruder calibration routines afterwards and tune this value further. They tell you to start around here. I know that I typically end up around 780 on my 3 other machines like this, but we'll keep it, 836. We'll keep it at that for now. Other changes to make. So we are essentially using a V6 hot end. So this has the thermistor type for the V6 in it. So you need to make sure that that is uncommented. And we've already done these. Okay. There are definitely more options you could play with in here. I tend to, on my Titan Aeros, enable linear advanced. So linear advanced is in configuration _ADV or advanced. And it's called lin advanced, the variable name. So uncomment this. I typically have this set to 20 on my Titan Aero machines or thereabout. But there is a calibration G code that you can get from Marlin's firmware that prints out a series of lines as the extruder kind of speeds up and slows down along the x-axis. And you choose whichever line value, in my case 20, looks the most consistent. When it changes velocity rapidly, there's kind of like a section that's skinnier than the rest of the line, or blobs at the end as it slows down. And you can always change this after the fact. So the fact that we're compiling it with linear advanced on here allows us to not use it if we don't want. You could just basically set this to 0 and flash it that way. But it leaves us open the flexibility of changing the linear advanced K value after the fact, after flashing, without having to reflash. We could actually define this K value in the machine start G code of our slicer program. So different slices even, you could use a different K value if that made sense. I don't see why that would. But this definitely helps with accurate extrusion as it changes speed or direction rapidly, resulting in things like sharper corners. So I'm going to leave this on. In my case, as I said, I normally know it's around 20, so that's a good value for me. But maybe it would be safe to set this to 0, print out the calibration G code I mentioned, and then just change the value from there. in your machine start G-code. So that's it. We're ready to upload. Perfect. So no errors, that's a good sign. So now we're ready to unplug from the printer, and let's go to the printer screen. So we've homed all axes, and before we did that, we made sure that we're going to have adequate clearance between the nozzle and the bed. We don't want it to ram in. This nozzle ends up at exactly the same height, or thereabouts, as the stock nozzle did. So after we've homed all axes, we know the mechanics are all working. Let's go to Control and initialize EEPROM. This is the best practice whenever you flash the firmware. This will make sure that, there we go, the values that were coded in the firmware are now loaded into the EEPROM successfully. So now we're ready to do maybe our test print or some calibration. As I mentioned when we were doing the firmware, we might want to print out the K-factor calibration test print and figure out if a K-factor of 20 is right for you, and you could use that in your machine start G-code. We also would probably want to do an extruder calibration to make sure that 836 steps per millimeter that we used in the firmware, which is E3D's recommendation, is actually extruding how much filament you're asking for. We'll cover that process probably in a future video. Remember, like, subscribe, and ring the bell, and leave a comment down below, and let us know what you'd like to see in the future. Thanks for watching.